Welcome to math. So do you remember back at the beginning, towards the beginning of the year when I taught you about the commutative property of addition? Do you remember when I told you that something like 6 plus 4 is the same as 4 plus 6? All they are is the numbers are just switched. We call that commutative property. So 4 plus 6 equals 10. 6 plus 4 equals 10, and 4 plus 6 also equals 10. Yeah, we call that the commutative property of addition. So today I want to introduce you to the additive identity. And the additive identity is when you are adding a number to 0. It stays that number. So 5 plus 0 is going to stay 5. And 17 plus 0 is going to stay 17. And we call that the additive identity. So you got the commutative property and the additive identity. Here, I'll show you. Commutative property and the additive identity, not property. Okay, so let me ask you something about the commutative property. If you know that 9 plus 8 equals 17, what does 8 plus 9 equal? Did you say 17? You got it. Yeah, when you have the same two numbers when you're adding and they switch and they go in the different spots, then they're still the same number. So let me show you. 9 plus 8 equals 17, and 8 plus 9 equals 17. It's all the commutative property. So that's a review of the commutative property. And additive identity is when you add a number to 0. All right, awesome. All right, so let's continue using our number line for adding and subtracting. So here's our number line. The tricky part today is that we're going to try to write a number sentence, which is, remember, number sentences and number models are the same thing. It's when you write something plus or minus something equals something. So let's start at 3. So I'll show you. Let's start at 3 first. And we're going to hop to 8. So we're going to find out how many hops it takes to get to 8. We're going to stop at 8. We're hopping to 8. So 1, 2, 3, 4, 5. So it took us 5 hops. So what I mean by this is we started with 3. We're adding some hops to get to 8. Okay, so we started with 3. We're adding some hops to get to 8. So how many hops did it take us? 1, 2, 3, 4, 5. So the unknown is 5. Does that make sense? So we're using the number line to help us write a number story or a number sentence or a number model. Number sentence and number model mean the same thing. All right, let's try another one. Start at 10, and we're going to hop back until we land on 6. So we start at 10, we're going to hop back until we land on 6. 1, 2, 3, 4, because we wanted to land on 6. So 10 minus something equals 6. So how many hops did we do? 4. Make sense? It's tricky. I understand it's tricky. You just have to do what they say. So let's do another one. So we're going to start at 4, and we're going to land on 10. How many hops to land on 10? 1, 2, 3, 4, 5, 6. So 4 plus something equals 10. How many hops? That's our something. Good. Let's try a subtraction one again. So we're going to start at 13. We're going to hop back to 5. So we can start writing our number sentence already. So we know that 13 is our first number. We know that we're subtracting because we're going back. We know that this is missing because we know that we're going to end up on 5. So we have to figure out what the missing number is. 1, 2, 3, 4, 5, 6, 7, 8. So this would be 8. Make sense? Perfect. All right, I'm sure they have a few more they want us to try. Okay, so now we're going to start on an unknown number. So if they gave us something like the unknown plus 2 equals 8, we have to figure out what this number is. So we are going to end here. We have 2 hops in between. So let's go back. I know this is addition, but we're going to go back because we're going from this way. So 8, we're going to go back to, what's the number that we started on? Yes, 6. Let's try another one of those. It's kind of tricky, but you just have to relax and do exactly what you're thinking. So I'll write the thing down again. Let's see, this one's going to be a subtraction one. So something minus 5 is equal to 5. So here's your unknown right here. So again, you're going, because this number has to be bigger, we're going to go the opposite way. So we ended at 5. We're going to make 5 hops. We ended at 5. We're going to make 5 hops to get to this number. 1, 2, 3, 4, 5. So that's your number. It sounds tricky, but you're just going backwards. Okay? So even though it's subtracting, we're going to hop forward because we want to get to that bigger number. If they told us this number and this number was missing, they told us the first number and this number was missing, then of course we're going to hop back to this number. 1, 2, 3, 4, 5. And then we know how many hops because we counted them. Okay? All right. Let's see. Let's do 9 minus something equals 6. So let me write it down again. 9 minus something equals 6. So again, because this number is missing, we're going to start at 9. But we're going to land on 6. So we want to stop here. We want to figure out how many hops. 1, 2, 3. So the missing number is 3. 9 take away 3 is 6. All right, let's try another one. Let's do 10 minus something equals 4. Same thing, going to start here. It's subtraction, so we're going to hop back because this number is missing. We want to land on 4 because that's what number is here. 1, 2, 3, 4, 5, 6. What's missing? The 6 hops. 10 take away 6 equals 4. All right, let's end with an addition one. But the first number is missing, so this is where it becomes tricky. Something plus 4 equals 8. So because this first number is missing and we don't know where to start, we're going to start at 8. And we're going to make the 4 hops. And we're going to figure out where we land. Okay? 1, and we're going backwards because we want this number to be smaller. These two numbers have to equal 8. So that's why we're going backwards, even though it's addition. So 8, so we've got 1, 2, 3, 4. What do we land on? 4. So 4 hops in between, that's that 4, equals the 8. Awesome. So we have 2 papers. So this one's going to be added to the activity in Seesaw. It's practicing what we did. This is the unknown. Okay, so you're going to use your number line and figure out what that number is. Same thing here. Same thing here, 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 here. Remember that look for addition and subtraction signs. That's going to help you. Okay, and then you're going to use this chart to answer these two questions. So roses and daisies, how many flowers in all? Remember, in all means all together, all of these flowers all together. Make tally marks to show how many flowers in all. So after you figure out the number of how many in all, you're going to show me tally marks. And remember, a group of 5. So make me groups of 5. Now, I did tell you one time that before you start any graph, if you figure out how many total and you write the number on the outside, that'll help you when you get ready to answer questions. So you might want to try to do that. Okay, and then you're also going to do page 32. 32 is math boxes. So I'll do a quick read. This is a rectangle. See it right there? Draw a different rectangle. Now, when they're asking for a different rectangle, it could be a different size. It could be a different way of, this one's going this way. You could draw one up and down. So that's what they mean by different. Okay. Write a number that is greater than 17. Greater means bigger than 17. If you need your number line or your number line or your number grid, use them. Which color do most children like best? So same thing, it's a chart. If it was me, I'd figure out how many was here, write the number. How many's here, write the number. How many's here, write the number. Then you can compare the 3 of them and figure out which color the children like the most. And then you're going to color in whichever one is the answer. Writing, reasoning, how do you know what the numbers are without counting? How can you look at this and know what it is? How can you look at this and know what it is? So this is another one of those explaining how you can see that that's a certain number. How can you see this as a certain number? Like I can see groups of 3 here, right? I know that 4 dots on the outside and 1 in the center is a 5. How do you see these? How do you know that these are the numbers without even counting? So explain to me over here. All right, so this will be an activity already on Seesaw. So I just want you to complete it. And then I want you to add page 32 to this activity. Take a picture, submit it to Seesaw. Have a great day.